SUG called linear measurement correction. What is the concept behind linear measurement correction? Has to do with survey. First things first, let's understand the concept of linear measurement correction. Let's say I'm a surveyor and I want to measure a land, right? So the process of me measuring that land is called linear measurement. Now, what the concept of the correction has to do with linear measurement is simply that there's no matter how you measure a length or a distance or doing survey, there must be always what? A mistake. So how do you erect the mistake while doing survey work? That's what they introduce what we call linear measurement correction. There are 4 ways of correcting these mistakes. We have number one, we have the temperature. Temperature correction. Number 2, we have the tensile correction. Tensile correction. Number 3, we have temperature correction, tensile correction, we have sag correction, and finally we have slope correction. These are the 4 main types of correction that has to work or that has to do with linear measurement correction. Let's take the first one called temperature correction and let's see the concept about that. Temperature correction. What is the idea behind temperature correction? Now listen, please. Whenever you survey, is measuring the length of the house, is measuring a land, there's what you need to note. From the standard of measurements of a land, the condition, the atmosphere must be cool. But in a case whereby the surveyor is measuring a land such that at that period of time, there is a high temperature, the sun is shining, high temperature. So there's no how mistake will not occur. Hence, you apply what we call the temperature correction. So let me give you the formula to this is given to be CT is equal to KL change in T, right? Where this change in T is equal to value to FT minus ST. This is the formula to solve problem under temperature correction. CT simply means temperature correction is equal to value to KL change in T, where this change in T is equal to FT minus ST. Let's name these parameters. We said K, where K is called the coefficient of linear expansion. Where K is called the coefficient of linear expansion, where L is called the measured length, change in T, or you call it delta T, change in T, or you call it delta T, is called change in temperature. Also, FT, we call it field temperature. Also, ST we call ST to be standard those parameters given them. So note that temperature correction is applied when there is what? When there is massive heat during the process of making measurements under survey work. And given by CT is equal to T such that T is equal to LT minus ST. Alright, let's discuss tensile correction. Tensile correction. Alright. For tensile correction, here you want to note, tensile correction is represented by CT, not C. Observe, temperature correction is what? C, small letter t. But tensile correction is what? C, capital letter T. So that's meant by CT is equal to M change in T over AE, right? M change in T over AE. Here's the formula for tensile correction. CT, observe, capital letter T, not small letter T. If I put small letter T, I'm referring to temperature correction of that. So when I put small letter T, I'm referring to what? Tensile correction. And we said it's equal to what? Length multiplied by change in tensile over area times Young's modulus. Let's define this. I've defined this to what? Measured length. Let's define this. Where change in T is equal to what? Change in tensile, right? A, we call A cross-sectional area. Cross-sectional area. Also, E is called Young's modulus. Young's modulus. Alright, let's proceed. E is equal to Young's modulus. Alright, so note that for the first time, temperature correction is applied when there is heat. Second one is tensile correction when there is an expansion during measurement of linear correction. So you apply tensile correction, which is given to be this. Let's discuss sag correction. Sag correction. Let's discuss sag correction. For sag correction, listen please. Let's say for instance, I use my tape to measure the length of the land. After done that, if you observe closely, there will be some parts when in such a way that let me assume this length are measured, right? There's no how. There will be a place that will somehow saturate this way. Do that measurement. If I measure, even if I use thread tape, there's no how. After making that tape finish, there will be a point whereby the tape will just go up and down. This is called sag. So, how do you correct this? During linear measurement correction, how do you correct for sag correction? And sag correction, put on this, sag correction is represented by CS. Sag correction is represented by what? CS, which is equal to value to W squared L over 24T. W squared L over 24T. Where W is W, let's define this. Where W is called the weight of tape. The weight of tape. Also, my length, L is called, as we defined L initially, that L is called the measured length, that's all. YT, this T is called what? Tensile, right? Tensile, that's all. So let's take the last one and let's solve a fast response under linear measurement of correction. The last one goes by what? Slope correction. Now listen please. There's no how in land. A land cannot be straight or true. It's impossible. So there's no how, you know how we slopey land. right? So if I have a land this way, there's no how a land can ever be straight. It will have command somewhere, right? So that how do you not correct such mistake? Listen, listen. If I measure this land like this, right? If I measure it, and if I have a land straight this way, if I manage my tape to measure this land this way, and let's say I have, let's say 5 meter for instance, and this from here to here, the same thing as from here to here. If I measure the distance from here to here, it will never be equal. If I measure the distance from here to here, I have 5 meter. If I measure the distance from here to here, it will never equal to 5 meter. It will rather was, let's say 10 meter. Because this one here has caused a change. Hence, how do you correct this? If you have a land that has this slope of the stuff, how do you correct it? That's why you apply the concept of what? Slope correction. Let me start slope correction. Sorry? Slope correction. For slope correction is given by SC. Observe this. We said for side correction is what? CS. Slope is what? SC. Do not make mistake. If you put SC for side correction, you are getting it wrong. Ensure that for side correction, C comes before S. For slope correction, S comes before C. And for my side correction, it will be given in 2 cases. Case 1 is that when you're having something like this straight, what do you do? What will you apply? Case 2, when having a sloping ground this way, what will you apply? It has different formula to solve them. So for my case 1, if I'm having a sloping, alright, for my case 1, having a sloping ground as I did initially, how do I correct it? Formula is given by SC, slope correction, is equal in value to 1 L into 1 minus cos theta. Here's the formula to solve slope correction for the case 1. For the case 2, if the inclined stuff is not in angle, right? So my case 2 now will not be, my case 2 will be slope correction is equal to h squared over 2n. So there's my formula to all these stuff. Please, that's the right formula. So as for us to solve problems involving linear measurement correction, let's take some past questions and let's solve past questions using the concept of linear measurement correction. Please, it's always come out every year. Every year. I'm going to treat the last year and the last 2 years question under linear measurement correction. Alright, there's something I omitted. We said for change in t is equal in value to lt minus st. What of change in t here? So my change in t here, my change in t, capital T, will be what? ft minus st. Still the same because the capital T must be there, right? Also, not something. Also, now, I will consider this. I will consider all this, right? Let's take a concept which is called horizontal length, right? Horizontal length. For my horizontal length, see, listen. If I give me a question under this, right? And I have to solve the question, right? For instance, I'm giving a question. After applying all these concepts to that question, jump in that question is what? Find a total horizontal length. So, and it's given by h is equal to what? Start with this. In that question, they will give you length. So, note that. I'll give you a past question and we'll solve it together. They will give you what? Length. Now, plus, let's start with this. Plus what? CT, also plus what? Plus CT, also plus what? Plus SC. This is my formula to solve true horizontal length of the linear measurement correction. Please note this. Let's take a question and let's solve it together. Alright, let's take an example under linear measurement correction. Put down this. Put down. A steel tape of weight 0.65 kilogram. A steel tape of weight 0.65 kilogram was found to have a length of 30 meters. I said a steel tape of weight 0.65 kilogram was found to have a length of 30 meters. Are you free? At a temperature of 20 degrees Celsius. At a temperature of 20 degrees Celsius and tension of 8 Newton. And tension of 8 Newton. Full stop. The tape was used in catenary. Have this catenary. The tape was used in catenary at a temperature of 16 degrees Celsius. The tape was used in a catenary at temperature of 16 degrees Celsius and tension of 6 Newton. And tension of 6 Newton. Full stop. The readings on successive sections. The readings on successive sections were 29.105 meter. I have 29.105 meter. Next up, comma, I have 29.876 meter. Right? Full stop. Calculate the true horizontal length. Calculate the true horizontal length of the line. I said calculate the true horizontal length of the line if the concessional area, observe, we mentioned that previously. If what? The concessional area of the tape, if the concessional area of the tape and Young's modulus were 4 meters square and 2 times 10 to the power 2 kilogram per meter square. Sorry, per meter cube, kilogram per meter cube, respectively. Full stop. Take thermal expansion of T as 0.0000113 / degrees Celsius. I said take thermal expansion of T as this value here, leave your answer in 4 decimal place. We are told to leave our answer in 4 decimal place. So how do I solve this? Our first task here is to apply the concept of science. What are first tasks? List out the given parameters, right? List out the given parameters. So my given, what am I given first in the question? Check, let's begin this. I'm told that a steep tape of weight was 0.65 kilogram. I'm giving weight. So my weight then is going to be what? 0.65 kilogram. Alright, I'm done with that. Was found to have a length of what? 30 meter, right? I don't need that, please. It simply means that that tape, the entire length of that tape is what? 30 meter. What I need from that tape is what? The weight. That's all. Which is this. Right? Let's proceed. At a what is? At a temperature of 20 degrees Celsius. Now listen. For every question on that linear measurement, the first temperature and tensile we see is for the standard temperature and tensile. Hence, observe. The question says what? It said of 30 meter at what? At a temperature of 20 degrees. That becomes what? Standard temperature ST to what? 20 degrees Celsius. Your first task is to observe. The first tensile and temperature given is called what? Standard temperature and standard tensile. Also, and tensile of what? 8 Newton. So my S capital T for tensile is equal to what? 8 Newton. Let's proceed. Now, the tape was in what? Catenary, right? At what? At a temperature of what? 16 degrees Celsius. Now, when you want to work catenary, it's simply a feed, right? So definitely my FT feed temperature now what is 16 degrees Celsius. Also, I'm tensile of what? 650. My tensile is what? That becomes what? F capital T what? 680. Alright, let's proceed. The readings are successive section where what? 29.105. That's the first length. So that becomes what? M1 is what? 29.105 meter. Alright, I'm giving on that length again what? 29.807. That's my L2. So my L2 because of this 29 point what? 876 meter. Alright. Calculate the horizontal length. True horizontal length. You said that what? H. Right? You said that earlier. When I wrote something here, H is equal to F plus CT plus capital T plus CS plus SC. I put that earlier. So what it was? True horizontal length. Alright. If the cross-sectional area, that's A, I mean, yes. A is what? If the cross-sectional area of the tape, I know what plus E is going to be what is 4 meters squared, right? Look at that parameter. Look at the way I am picking out parameter. Ensure your parameter are picked out carefully, right? So you don't make mistake. Alright, my youngest work is 2 times 10 power 2 kilogram per meter cube. Alright. Respectively. So take what? Thermal expansion. That's K. We measure K, right? In what? Thermal expansion. My K, hence my K is what? 0.1234. Is it what? Yes. Then what? 113 degrees Celsius. So, and I said, leave your answer and what? For the decimal place. So, how do you solve this? How do you solve this problem? So, our first task observe this. For all this, what do you call it? Parameter, our first task is to listen. All the formula I gave you initially, we're going to apply each of them to solve this question. Now, we have just L1 and L2. If I have L3, listen, in science, when you learn that parameter, it tells you what to do. It tells you where you are going, where to start from. Now, look at this question very well. I have L1 and L2. All the parameters I gave, all the formula I gave you, temperature correction, tensile correction, side correction, and slope correction. All the formula I'm going to apply to solve L1 separately. Of that, L1 separately. Hence, that same formula I gave, temperature, tension, downside, and slope, apply to L2 again. Then after that two answer I will have, I'll combine them together to have my true horizontal length. Let's have this solution. Now, listen please. Let's take this way. N1, let's take as grade 1 and grade 2. Or say part 1, part 2. Let's take it as grade. Let's start with grade 1. Grade 1, Abby? Grade 1. What is the name of grade 1? 29.105 meter for my grade 1. Right? This is grade 2. Or part 2, part 1. Let's start with part 1. Let's now apply to part 1. Let's apply all the formula to solve part 1. Hence, that becomes what? Let's start with what? Temperature correction. So that becomes what? Temperature what? Correction. What is it? That's what CT is equal to what? KL changing T. Right? KL changing T. Let's put the parameter. But we said change in T is what? Change in T is equal to what? FT minus ST. Hence, let's get to the T. After this change in T, put the value here. Multiply by the length, which is this. By what? K, which is this one there. And get CT. Right? That becomes what? Change in T is now equal to FT is what? FT is what? 16 degrees minus FT. ST, what is ST? 20. Hence, my change in T is what? That's minus 4.
Yes.
Minus 4, right? Minus 4?
Yes.
Minus 4? Yes. Alright, my change in T is minus 4. Now, what is minus 4 inside this formula? So, to get temperature correction, that's what CT is now equal to K is what? 0.123 4 113. Multiplying what? My length I'm considering is what? 29.105, right?
Yes.
Multiplied by this 4, which is what? Change in T. So minus 4. Give me value this. My hence temperature correction is equal in value to multiply all this with this.
Minus
this
0.00.
Minus
0.001315.
Let's look at this point. Right? Temperature is in what? Degree Celsius. So this is my what? Temperature correction for my day 1. Let's consider what? The tensile correction, right? Tensile correction. So this is what? Saying that CT is equal to L what? Change in T over AE. Right? Now, I know all my change in T. Let's do T. But we said what? Change in T is equal to FT minus ST. Let's put the parameter. I'll have change in T is equal to this. FT is what? The constant. FT, that's 6 Newton.
Yes.
Minus what? ST. Check all what? ST is what? 8 Newton. Hence, my change is what? Is
minus 2.
Minus what? Newton. Minus 2 Newton. Hence, if I put minus 2 Newton inside this formula, I'll have what? CT of that. CT is equal to L is what? Now considering what? 29.105 times T is what? Minus 2, right?
Yes.
Minus 2 over
equal to minus
everything, I
5.
mean,
No.
for the numerator. Oh, minus what?
Minus 58.21.
58.21 over when this I have 800. Divide these two, please. Divide minus 58.21 by 800. Give me value. So my CT will equal value to minus 0.
Minus
0.072, right?
Yes.
So let's do 7. That was a new thing. Why? Then side.
Only 7, not 2 7.
Okay, 7 2. Okay. 7 2. This way.
Yes.
Let's confirm. So I know what? Terminal correction. Then side. What next? Side. Right? Side. I mean. Hence, I'm doing what? Sorry, side. Yes, side. Side correction. See, I'm showing it. Listen, see, I'm showing this question. Pick out your first length. As title, they won't be my length. Apply for the formula to solve it. For this man, I apply physical correction, temporal correction. For this same man, pencil correction. For that same man, what? Side correction. Also, correction. Right? So, my side correction now what, please? That's what? SC or CS. That is what? CS. Don't make mistake, not SC. CS. So it's what is W squared over what? 24C, right? Let's follow our formula to side correction. Also, I thought something about side correction. For every side correction, it must be always what? Negative. If you have positive answer after solving it, always put negative. Side correction is always assumed to be negative. Also, that becomes my weight there, my parameter, I'm giving what? 0.65. Hence, by putting 0.65 here, multiply all squared, right? All squared, multiply length. Which length am I considering? B1, this length, right? That was this. 20 what? 29.105 all over 24 times. This is what is this thing? 10 side, right? 10 side. So, what is my 10 side? How do I do this? What my 10 side? Right? My third was 10 side is this man here. Which is this? CT, that's a correction. So my 10 side is what? This man. So putting that man there, that was minus 0 point what?
0072.
0.072. Punch out numerator. Just punch numerator. What are the value? CX is equal to punch this square times this.
It's called the 12.29.
12 point what?
29.6.
29.6 over punch denominator. Give me value. Now minus something. Hence
minus 0.172.
minus 0 point what? 172. 172, right?
Yes.
Divide this, please. Divide this, please. Divide this, please. Divide this.
Minus 71.4.
Minus what? 71.488. As what? Slope. Meter, right? Meter. So, we have certainly what? Looking for temperature. 10 side. Side, right? On the left. Slope. And this now comes your correction. Is there angle of contact here? Is there angle here? Check in your parameter in the question. Check your question. Is there angle in the question? No angle, right? So hence, I don't need slope. I'm not going for slope. But in a case whereby in your question you are given angle, apply what? Slope correction. But in this question here, there was no what? There was no angle, right? During my exam, this was my question, right? The person they gave us last semester. It was very funny because the lecturer actually gave us questions. Because I gave us a class, I had angle. So we were all confused. In the exam, he gave us questions. There was no angle, right? I was was surprised, but I knew myself that I'm not solving for what? Slow correction. But my other person that we use, they are even solving, so none of them solve slow correction. But in the question, what's the correction in the question? So please ensure that you pick that parameter very well. And if you pick that very well, it lets you know where I'm going. Right? So this is all I need here. Now, let's calculate for my true horizontal length for B1. Because what? My true horizontal length becomes like this. My true horizontal length H becomes what? We said recall that we said something that we said that we said that what? H is equal to N plus what? CT plus C capital T plus CS plus SC. But this is slow correction. Is it even the no? Hence, I will erase this out. I'm done. Now put the value. My H is equal to N is what is? This is what? 29.105 plus CT is what is? CT.
0.00.
What is it? Okay, minus that.
Yes, minus.
And it comes minus 0.001335 also plus, give me CT. See my value?
Yes.
Minus what? Is 0.007 what? 72. Also, lastly, slide correction is what? Minus what? Minus 71.488. Give me my total length, please. Give me my total length. What's my answer, please? My H is equal to what? Give me value, please.
Minus 42.
Minus
42.
42.
Point 38.
Point what?
39.
39.
15.
15. Alright, now listen. I'm not stop here for all of us today, right? But here's the concept. We just did for what? N1.
Yes.
What can you for N1?